So there's a question in the assignment about Taylor series. So I thought I'll give you another example that will reinforce the idea. Use Taylor series method Taylor series method. I just put TSM to find and y 1.2 correct to given that the differential equation dy dx is equals to xy to the power of 1/3. And the initial point at x not equals to 1 is 1. It's like x naught is y naught. So you know that your x naught is 1, y naught is 1, and the step size is given 0.1. How we know the step size? Because we are given an initial point. We are given this initial point here, right? And we are told the initial point is 1. The x value of the initial point is 1. The y value is also 1. So you're told to find 1.1, 1.1, and then 1.2. You were told to find y value at 1.1. The next value is 1.1 and 1.2. So the step size from year to year is 0.1. Okay, so the next step also plus 0.1. So that's how we know the step size. So there are several ways of doing this thing. Remember earlier on we did, of course, we used the same formula. So y prime, you can write your dy dx as y prime. Y prime is xy 1/3. So y prime x naught is equals to x naught y naught. Okay. Next, before I move on, look at this formula, Taylor series formula. This Taylor series formula wants you to find correct to 3 decimal places. Okay, another small piece of information is missing here. Let me include this here. Correct to 3 decimal places, taking the first three terms. Of the Taylor series formula. The general formula, Taylor series formula, we know x plus x plus h. X is like the initial point, h is the step size, is yx So this is the Taylor series. So this problem just want you to take the first three terms. So this is term 1, term number 2, and then this is term 1, this term 2, and then this is term 3. They just want you to use three terms. Okay, three terms. The third term happens to be the second order. Second order Taylor polynomial. By taking three terms, actually you're solving for second order Taylor polynomial. So that means you have to find the second order. So take the derivative again. Y double prime, because the formula needs it. Y prime is, so you have to do, take the derivative again. So for example, let me rewrite I'm doing this slowly so that people who having problem with derivative, they can see. For example, you apply the product rule. You they call this U. You call this U and V. Okay. The product rule. You have a product rule U V prime. Is U prime V plus U V prime. So you apply that rule. For example, you can assume U is equals to X, and then V is equals to Y to the 1/3. So you do the second derivative. Which is U prime V plus U V prime. U is X, right? U is X, so U prime is 1. V is Y to the 1/3. U was defined to be X, V prime. You take the derivative of V is this. V is Y 1/3. Take the derivative of that. 1/3 Y 1/3 minus 1, and then multiply by the derivative of what is inside here. Multiply by the derivative of what's inside the parentheses, which is just Y prime. Y prime shows 1/3 Y minus 1/3 Y prime. Okay, is that clear? Sorry, it's 2/3. Yeah, that's a mistake here. 1/3 minus 1 is minus 2/3. I forgot the x. Is this okay?
Yes, sir.
Anybody still confused about these things? So you have to know how to do this type of things. So what you're doing to y is you are doing an implicit differentiation. On this one, you're doing an implicit differentiation. Okay, after that, taking the first three terms, so which is y. Let me rewrite that again. The first three terms is yx plus h y prime x plus h squared y double prime x over 2 factorial. First three terms. Y x naught plus h. I'm just doing this here in detail. Maybe you don't have to write this much. You really know what you're doing. Just replacing the x with the x naught. X naught is the initial point and h is the step size. So if you want to find, we want to find, call this y1, and y1 is equals to y1.1. This is what we want to find. We want to find y1.1, the value of y at 1.1. So 1.1 is the value of y at 1.1. So this is the x value. X value is 1 plus the step size 0.1. That's what it means. So please note that x naught is 1, h is 0.1. So x naught is 1. Wherever there's x naught, you put 1. Wherever there's h, you put 0.1. Okay, any problem? We can come and evaluate what is y prime. You can evaluate this here. So you need to find what is y1 prime. Y1 prime 1. Y prime 1 is already given to you as 1. y1 prime 1. You go back here, you need to see is x, y prime.
Hi, sir.
Yes, yes, please be quiet, you know, lectures going on here. Come late, somehow disturbing the lecture. Okay, so this is the formula. Now you have substitute y1, x is 1, so y prime, so x is 1. And so this is same as, please note that this is, the y here is same as yx, okay? Yx 1/3. So for information, so I can just write it here. It's a function of x is understood, but usually we don't write. So y prime with x equals to 1 is y 1/3, which is 1 and then y1 is also 1, right? 1 to the power of 1/3 is also 1. So 1 times 1 is 1. Any question?
No, sir.
Okay. So what we really doing, I forgot to put here, okay, x naught, y, x naught. So we just plugging in the x naught. We already know that x naught value was given as 1. So we just were plugging in those values. So next, you try to plug in the evaluate y double prime. So this is y double prime. Y double prime is actually is a function of x. So I'm just putting this x here to ensure that you know it's a function of x. Okay, they are function of x, just for information. So now we're going to evaluate it at x naught. So this is just illustrating these things in detail. So in the exam, you don't really have to write too much if you know what they are. But you know, please be very clear when you write. This -2/3, you know, you can put like this, or you can also, if you don't like to write this way, you also can write like this. X not 1/3. Same thing. So x naught is 1 plus 1/3. So wherever, okay, it's x naught, x naught, x naught. Okay, before I can move on with this, I want to do something here. Let me go ahead and redo this part here. So after you took the derivative, right, second derivative, okay, we don't like to write this x. There's something is missing here. There's a mistake here, right? Do you guys notice it? Okay, before I can move on with this, I would like to do this again. Y 1/3, y prime, okay. So this part is okay, the derivative part, okay. So you just want to, if you're confused, you just want to mention that y is yx, you know. If you're confused, you can just write like this. So over here, what I'm going to do, plus 1/3. You don't have to do this, but I'm just doing this. Later on, if you do this simplification, the evaluation becomes easier when you plug in numbers. So I'm going to replace the y prime. Go back here. I'm going to replace the y prime with this x. As I said, you don't have to do this, but later on the later part, when you have replaced the y prime with this. Y 1/3 plus 1/3. X times x is x squared. And then y minus 1/3. When you do this, when you later on, when you plug in numbers, it'll be easier to evaluate. Now you plug in those numbers. So this is 1 plus 1/3 multiplied by x naught. X naught is how much? It's also 1 squared. And then you have y naught, also 1, right? To the power of minus 1/3. If you evaluate this, you're going to get 1 plus, everything is 1. So all this is 1/3. It's equals to 4/3. Does it look good? Any question?
No, sir.
Okay, so I mean now you can evaluate this equation here right now. This y1 that we already written this earlier. Sorry, this is okay. So y1 is going to be, this is 1. This is y prime 1 was how much? Do you guys remember? It's also 1. And this, we just calculated this as 4/3. One plus 0.1 plus 0.0 0.01 divided by 2 multiplied by 4/3. How much is that? Right now, y1 is 1.1066. Continue to go until 6. So if you want it to be in 3 decimal places, then it's going to be y1 is going to be 1.107 to 3 decimal places. So y1 is, for now we can just say y1 is then x1. In this case was x1 plus x0 plus h, which is 1 plus 0.1. So x1 is 1.1. Any question?
No, sir.
So in short, x1, when x1 is 1.1, y1 is 1.10. For now, I just put 6610 because I need this value. Although you want the answer into 3 decimal places, but I'm going to use 4 decimal places because I need this answer to find out y2. So I have a one decimal place bigger than 3 decimal places. 3 decimal places is the final answer. But to plug into the next equation, I'm going to use 1.1066. So the next equation, what you're going to find is you're going to find y2. So initially you were here, you already find x naught, y naught. Then you already found x1, y1. Then you want to find the next one, x2, y2. Step from here to here is 0.1. Step from here to here is also 0.1. y2 is y1.2 is equals to y1 plus h. So you're not going to use y naught anymore because you already found this value. To be able to find the next value, you are here now. Earlier you were here. Right now you are here. You are here now. So you start from x1, y1. So this derivative has been done for you earlier on. You can simply use them. We already have this formula from the last time, but the same formula, but the subscript now is y1, not y naught. What is y1 is actually y1 x1. Or simply you can say y x1. That's what y1 is. Plus h So, all right, is this formula clear? Okay. Are you guys still online? Can you all see the screen?
Yes, sir.
Okay.
Yes, sir. Can.
Okay, so we know we already found. So I'm going to use found y1 earlier, 1.1066, and then y1 prime is x1, y1 to the 1/3. X1 was 1.1, y1 was 1.1066, 1.138. y1 prime, y1 double prime is 1/3 x1 squared y1 minus 1/3 plus y1 to the power of 1/3. We evaluate this at x1 point. $1.1066 You punch it in. You will get 1.4249. Then y2 is 1.10. Y2 is this formula here. This is the formula. You are going to put them all together. It's going to be 1.10. So this is same as I said, y1. I'm just, you don't have to use x1 inside there if you don't like. This is y1 prime. Y2 is 1.1066. Multiply by 1.138. It's coming from here. It's coming from, this is h, and that's h. This is y1 prime. Y1 prime is this, 1.138. Then next is h squared, 0.1 squared. H squared divided by 2 is y1 double prime. Y1 double prime earlier was, we calculated this to be 1.4249. We calculate y2 is approximately through 3 decimal places is 1.228 to 3 decimal places.
Sir,
Uh-huh.
for the second derivative,
Uh-huh.
I'm using calculator to calculate the answer is 1.42439. So,
Oh, really? Or maybe there's a typo error
yes, sir.
on this one.
The second, yes, sir.
1.42439.
Yes, sir.
Okay, so 43, maybe I made an error when I'm copying this. So there could be some problems here. So if you use this value, maybe this value might change a little bit. 1.424. So we round off maybe 1.424. Round this off to 4 decimal places. 42. So if you calculate this, what do you get?
1.22x.
Okay, see, the final answer somehow come out right. In between, it was messed up. Thank you, JJ. Okay, so then next you write this as y2 equals to y 1.2, which is 1.228. And x2 is x1 plus h is 1.1 plus 0.1, 1.2. So that's how you find it. So this is the assignment. Yeah, you're supposed to use your assignment also something similar to this. Let me look at the assignment that was given to you. So same formula can be used. Sometimes the formula, instead of using h, we were using, sometimes we use, instead of h, we use x minus x naught, right? It's the same thing, right? If you're using, let's say the point you want to find, let's say the point x, this is a 1.1, and then minus 1 is also giving you 0.1, right? Okay. So the step size, that also gives you x is the point of interest. X naught is the initial point. So the point of interest minus the initial point also gives you 0.1. So they are doing the same thing. The assignment 2. Determine the Taylor series polynomial. Assignment 2 is much easier than what I'm doing now. Okay, maybe the secondary, you only have to Taylor series polynomial of degree 4. Maybe you have to degree 4, that means you have to go up to x to the power of 4. Okay, in your assignment, it's given dy dx. Dy dx is x minus x y squared, right? And then it's also given u y0 is 1. So this is x naught, and that's y naught. And they ask you to calculate x is 0.1, y is 0. So the step size is given to you. Maybe, let me see. So this is the step size is given. So this is the step size is given to you. We find the Taylor series polynomial dy dx. One second derivative. So this is the first derivative. Then you find the second derivative. Fourth order means you have to go second order. You have to find that. And then you have to find third order, third derivative, fourth derivative. After finding this fourth derivative, and you go and build your Taylor series polynomial. Build your Taylor series polynomial using this formula that was given to you. This formula was given to you. Okay, I'm going to change this problem to something else. Okay, you instead of finding it, because this might be okay, that's fine, because okay, there's no change because the initial point is 0. Okay, the initial point is 0, right or not? So the next, so you're going to use 0 plus 0 0.1. So this is 0, this is 0 0.1, and this is 0, correct? So you have to build this plus until h cube 3 factorial plus h to the power of 4. Fourth derivative. The only part that you have to find, you may be having some work to do, finding the derivative. So you just have to find this. It's much easy than what we did. Okay, any question? First derivative, you guys know how to take the derivative, right? So it's given, first one, minus xy squared. Then you have to take the second derivative. It's 0 minus x 2y plus 2y y prime. Something like this. So you have to continue. Step by step. Okay, let's move on to the next question. Any question? Any question?
No, sir.
Okay, now we have one problem involving dominant eigenvalue, eigenvectors. So before we just did some simple problems. Find the largest eigenvalue and eigenvector. Given this matrix, can find the largest eigenvalue and eigenvector. So the assignment, you have a question like this, then you were told to assume an initial value of 101. You also can assume other values. Let the initial value, let's assume an initial approximation Okay, you also can do this. If you find the calculation too long, you can do this in MATLAB. So first, you do an initial guess. This time, you're going to guess 111. Last time, in the assignment, you are told to guess 101. But in this problem, I'm using 111. So this is the initial approximation. Okay, after you find the initial approximation, you multiply the matrix with the initial approximation. This matrix. Initial approximation with the initial approximation 111. If you multiply them out, you know how to multiply, right? I'm going to ask you guys to do this by yourself. It's quite boring, you know. Right? It's 10 plus 4 minus 1. The next one, second row, is 4 plus 2 plus 3. Third row, multiply by this, minus 1. You're going to get 13.
But sir,
9. Yes?
it's supposed to be a -1, sir, not -3.
Okay, minus 1, thank you. Okay, 3. 1393. So you guys know how to do this, right? Matrix. 1393. So you factor out the largest number. The largest number in this vector, in this matrix, what is the largest number? Nivedyan, huh? Nivedyan, what is the largest number? Nivedyan, Nived,
13, sir.
huh? Cutting,
13, sir. 13.
Oh, you said 13. Okay. Factor out the 13, then you get 1.0, 0.6 to 930, 0.23, 0.76. So you want to, when you do this problem, you want to keep at least 5 decimal places for accuracy. 5 decimal places. Keep 5 decimal places because these are iteration problems. We cannot round off too much. So therefore, AX naught is 13 multiplied by 1.0. Just rewriting this. Or maybe no need to rewrite this. It's already there. Okay, never mind. 1.0 which is, you can call this 13x1. So this is, for now, this is the eigenvalue. For now, but this is not the correct value. This is the eigenvector. But these are not correct. You have to do many, many iterations. You have to keep on doing until you see that your eigenvector is converging to specific values. When they don't change anymore, then you can conclude that you have obtained the eigenvalue and eigenvectors. We will see how to do that. Where x1, so now you have a x1 new set of vectors. So we started with the initial guess. Now we have come up with a new set of values. Now you continue the process. Now you take this matrix again. Go ahead and take this matrix again. And do this. Matrix A multiplied by x1. you continue with this. If you continue with this, multiply again, when things become decimal, now numbers are becoming more nasty. You can see they become more decimal places. So it's kind of not very convenient to multiply and add them. That's why if you do this in MATLAB, it'll be convenient. If you have a good calculator, that is a blessing. Multiply that vector, you'll get 12 point. I don't know how correct these answers are. You can check later. But the most important thing is the procedure. You factor out the largest number, you get these vectors. So now you have a new set of vectors. So this is called x2. Okay, now if you look x1 and x2, so this is your x1 right here. If you look at this, and if you compare with this x2, so are they the same? No, right? Maybe one is same, but on the second row, you have 0.62930. On the second row, okay, the first row, they are the same. On the second row is 0.62930, but here is 0.48466. On the third row is 0.23076. And here is 0.10429. You can see they're different. Second row and third row, oh, they are different. So that's why you have to have them in many decimal places so you can see the difference clearly. If we go and simplify this to 0.1, say we put this as 0.2, and then if we put this as a 0.1, then you will go and say, oh, not much difference. What? So you will make a wrong conclusion. So that's why you have to have many decimal places. Same here, if you round off to one decimal places, you will say, okay, this is 0.6. And then you will say, okay, this is 0.5. Not much difference, what you will say. That's why you have to have many decimal places. So they are not the same. So you have to continue the iteration until they are not changing anymore. So when they're not changing anymore, so you continue the iteration. So you continue the iteration until they don't change. They, you know what I'm referring to they here, right? They don't change anymore. What I mean is, like, for example, x1 and x2, in this case, they are not the same, but you will come to a point when the subsequent vectors will not change. That's what I mean by they change until they don't. So you continue the iteration until there is no change. I just put here quotation mark. I'm just talking about this right here. So subsequent vectors, they don't change anymore. No matter how many times you repeat the iteration, they don't change anymore. That means they reconverge to the eigenvalue and the eigenvectors. So the eigenvector will be this one, this figure here. But you look at the eigenvector, eigenvalue is this figure. Sorry, this is the eigenvalue and this is the eigenvector. So you continue the iteration. Next, you go ahead and find, any question?
No, sir.
No, sir.
Okay.
No, sir.
AX2, same thing again. Lazy lecturers, they don't like to write a lot, so that's why I copy and paste. X2, (1.0), 0.48466, 0.10429. Go ahead and multiply. Eight three four three six. 83436, 5.220, 0.55, 828, multiplied by, okay, that's the answer. So you factor out the largest number from here. Eight three four 83436, 83436. I think there's a typo error here. This is okay. 83436. So if I were you, I will do this by hand, and then maybe I'll do by MATLAB and then check it with hand. So you will get the correct answer when you submit. Okay, now you have the third eigen. So you can compare these two and see, are they the same? I think they're getting there. The second row, for example, the first row, okay, still the same. The second row is getting closer. The second row is getting closer, but not the same. The third one is quite far away. So you have to continue until they don't change. So this is equals to 1183. Maybe there may be some mistakes, when I'm copying things, numbers. So, but don't worry about this. Where where x3 is this. Now you continue the next iteration. It's tedious. That's why we have computers. They will be very happy to do repetitive work. They have a processor that can repeat things forever. So in the exam, you are welcome to use MATLAB. If you have to do something by hand, of course, since you are doing this online, you may check your answer if you like, but that will take time. Why don't you just do it by hand? Simply correctly, because what are you going to get in the exam? Very simple problems that can be done quickly. So this is x4. Next, we will do x4. And that's still a long way to go. You have to do how many more iterations? Like maybe a few more. Okay. What, Betty? AX5 is 1.0. Factor out the largest number from the vector. Factor out the largest. Okay, when you come to this point, you can see they're not changing very much from this point onwards. Like, we look right here at this and this. If you round it up to 2-3 decimal places, and then you can see they are the same. If you pretty much the same. Like, you know, you have to do a few times and see, like, they have to be consistent. See, from here on, they're not changing. From here, they're still almost the same. Okay, it's almost the same. So they should be stay consistent for a few iterations, then you can make a conclusion. Okay, so you cannot go on for many iterations. It may take hundreds of them to converge. But so when you see after a few iterations, they are not, I mean, they are staying the same, then you can conclude this part also, the eigenvalue part also staying pretty much the same. Okay. So when they are not changing very much, then you can conclude not changing, very much from previous iterations, from the few previous iterations. So this is the judgment that you make. Okay, this also not changing very much from the previous iterations. So therefore, I can conclude from here, therefore, the largest eigenvalue and the so okay. So when they are not changing very much from the previous, then you can conclude this is your eigenvalue, eigenvector, same thing that I wrote below here, eigenvector, eigenvalue. Okay, that's all for today. Any questions? No, sir. Are there any questions?
No, sir.
No, sir.
So in your assignment also you have to do quite a number of iterations. And I remind you again, don't copy answers from the friend. This time